Hey, Mr. Estrada here, and our learning target for this video says I can determine if two triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So our first example says, in the diagram of triangle ABC and triangle DEF, below AB is congruent to DE, BC is congruent to FE, and angle B is congruent to angle E. Which method can be used to prove triangle ABC is congruent to triangle DEF? So we want to begin by labeling the given information. So always start these type of questions that way. Label the given information. What we are given is that side AB is congruent to side DE, and that means that they're both the same length. And we indicate that by putting a tick mark on AB and a tick mark on DE. We are also given that side BC is congruent to side FE. And this time I'm going to put 2 marks on BC and 2 marks on FE. And the reason it's 2 marks is because I want to distinguish between the given information. Then it says angle B is congruent to angle E. So now it's saying that the angle here measures the same as the angle here. So that's the given information. Now to decide which method can be used to prove that the triangles are congruent. So we basically have 5 methods, and I'm going to just go over the 5 methods very briefly right now, and then we'll decide which one is the appropriate one for example 1. So we got the side, side, side postulate, and it basically says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So if you look at the diagram here, side GF is congruent to side PR, side GH is congruent to side PQ, side HF is congruent to side QR. And since that's the case, then we can say the triangles are congruent by side, side, side. I'm not going to read through all of these. I'm just going to basically point out the diagrams. The side angle side postulate says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So just take a look at the diagram. This is what a proof by side angle side postulate would look like if you labeled. So what it says, 2 sides and the included angle, what it means by included angle, it's the angle that's in between the two sides that you're using to prove the triangle's congruent. So angle C is the included angle, and angle D is the included angle. So included angle just means in between the 2 sides. So that's the side angle side postulate. That's what it looks like. The angle side postulate right over here. So you have angle congruent to angle, side congruent to side, angle congruent to angle. And this time it's the side that's included. It's the 2 angles and the included side. Then we have the angle side theorem. And the difference between this one and angle side angle is that here the side is not included, meaning you see if you look at the angle side angle postulate, the side is included right between the 2 angles. Here it's not included, it's not between the 2 angles. So by included I mean it not in between. That's what it means. Don't get thrown off by that word. And the hypotenuse leg theorem, we only use the hypotenuse leg theorem to prove right triangles are congruent. So I'm going to write that only used for right triangles. So this is, you would use HL if you want to prove that you have 2 right triangles congruent to each other. Okay, so let's go back to example 1. And which method could we use here? Well, we can't use side, side, side because we would need 3 we would need to show 3 corresponding sides are congruent, and we only have 2 corresponding sides are congruent. And it's not HL because we're not dealing with a right triangle. We don't have like a right angle. And it's not going to be angle side angle because we only have 1 pair of corresponding angles. So by process of elimination, you are left with choice 2. So the answer is choice 2, side, angle, side. And you can see it here, side congruent to side, angle congruent to angle, side congruent to side. And the side is, the angle is included, meaning it's in between the 2 sides. So this is example 1, it's side, angle, side. Let's go to example 2. Example 2, so remember, you want to begin by labeling, label the given information. Always begin with that. So it says here, AC bisects angle BAD. Let's go over what that means for a second. AC bisects angle BAD. So what that means is that angle BAD is being split into 2 equal angles. So angle BAD is right over here, it's angle A, and from this information we can conclude that this angle here is equal to this angle here because of the bisector. And then it says that angle BCA is congruent to angle DCA, and that's saying that this angle here is congruent to this angle here. And that's all we got so far. Then we are asked which method could be used to prove that the triangles are congruent. Looks like I left the answer there. Let's get rid of that for a second. So what method could we use to prove that the triangles are congruent? Well, you might be saying right now, well, the only thing I know is that 2 pairs of corresponding angles are congruent. I know that this angle is congruent to that, this angle is congruent to that, and you need 3 things. So what do? So we have to think of, maybe there's something else here in the diagram that I can say is congruent. And there is. You can say that side AC is congruent to side AC by the reflexive property. So that would give us choice 4, angle, side, angle. And let me explain that a little bit more about the whole reflexive property thing. If you were to split these 2 triangles up, say you were to split them up, you'd get something like this, wouldn't you? You can see very clearly here that side AC is a part of triangle ABC, and side AC is a part of triangle ADC. So it's like a side that's being shared, and that's what we mean by reflexive property. Example 3. In the diagram below of triangle DAE and triangle BCE, AB and CD intersect at E such that AE is congruent to CE, and angle ADE is congruent to angle CBE. Triangle DAE can be proved congruent to triangle BCE by, so again, you want to label. So let's begin by labeling. AE is congruent to CE, and then it says angle ADE, this angle here, is congruent to angle CBE, this angle here. So which method can we use to prove the triangles are congruent? So again, you're wondering here, well, I only have 2 corresponding parts. that are congruent. You need a third part. So where does that come from? So again, look at the diagram. Is there something else there that's not being explicitly said? And there is. You have a pair of vertical angles here that you can say are congruent to each other. And now we can say that the triangles are congruent by the angle side postulate. Now, in case you're wondering, why can't you say that this side is congruent to this side? They look like they're equal, they look like they're the same. Well, that's why, because you don't really have any proof, any evidence other than they look like they're equal. And you need something more than that. You need something more concrete. And so this is more concrete, the vertical angles. Example 4, in the diagram below of triangle AGE and triangle ODE, AG is congruent to OL and AE is congruent to OD. To prove that triangle AGE and triangle ODE are congruent by SSS, what other information is needed? So let's label AG congruent to OL. They already labeled AE and OD for us with 1 tick mark, so we're going to use 2 tick marks for AG and OL. So if I want to prove these triangles are congruent by side, 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 I don't need another pair of corresponding congruent angles. What I need is another pair of corresponding congruent sides. So I need this side right here congruent to this side. And then I can say they're congruent by side, side, side. So the answer would be choice 1. All right, so tomorrow we're going to be working with HL. That's going to be it for this video. I hope this helps. Take care.